So the question that we're going to do first, find the exact value of the 6 trig functions of the angle theta if 4, -3, so highlight 4, -3, is a point on the terminal side. So all you got to do is draw your xy axis and let's put down 4, -3. That would be in quadrant 4. So 4, -3, and there's your dot. Now that's going to be important. The way you're going to draw this triangle is you always connect to the origin like that and drop to the x-axis. There's your theta right by the origin. So again, number 1, connect to the origin. Number 2, drop to the x-axis. I cannot emphasize this enough. A lot of people get this wrong because they go to the y-axis. The reason we always go to the x-axis is because the whole angle system is based off the idea that 0 degrees is right here on the x-axis. So because of that, everything is based off the x-axis. Now, to figure everything out, we're going to start by writing our 6 trig functions. Sine theta, cosine theta, tan theta, cosecant theta, secant theta, and cotan theta. And on our triangle, we're going to fill in the legs of this triangle. So we know that this is 4, and this is important. Even though the distance on the opposite is 3, you write -3 because we're talking about components. This isn't really geometry. It's more the y component of this triangle. And hypotenuse to Pythagorean theorem, you're going to get 5 here. And the 5 is actually referring to a length, so this thing is actually always positive. Only the x and y components could be negative. Hypotenuse is actually always positive. Once you have your triangle, let's figure it out. Sine theta, that's -3/5. Cosine theta, 4/5. Tan theta, -3/4. Cosecant theta, -5/3. And again, we're just flipping it here. So I'll just go a little quicker. And there we go. Those are the 6 trig functions of the angle theta. Now for our next part, it says using a coterminal angle. So highlight coterminal angle here. So to do that, I'll give you an example here. The idea of coterminal angle is that you can add or subtract 360 degrees freely. So think about let's say this is 30. If I do 390 right there, notice how it's the exact same position. So that's the idea of coterminal, is that you can add or subtract 360 and you don't actually change the position of the angle. So we're going to do this. First example right here. Let's draw a line. It says sine of 390. So 390 is not in our circle, so we're going to subtract 360. That's the whole idea of coterminal. And we get sine 30. So that's much easier to figure out now. Now we're going to do the circle techniques we've been practicing. Here is my circle. 30 degrees is right there. Notice how it's sine, so that's going to be the y value. This is a small distance, so notice how it's small. And it's positive. So the answer must be positive 1/2. Next one. Cosine 420, let's subtract 360. So that would be cosine of 60. That's right there. Now we're talking about the x value. If it's the x distance, that's horizontal distance. That's here. So notice how that is, again, a small value. And it's in quadrant 1, so it's positive. The answer is positive 1/2. Next one. -7 pi over 4. So to make it easier, let's add 2 pi or 360. So now we have secant of pi over 4. That's simply 45 degrees, so that's in the middle. And what I think is, I think cosine of 45, that would be easier, because we know that this is the x value, it's in the middle, so it's our medium, and it's positive. Cosine 45 is root 2 over 2. We want secant 45, so just flip it. Answer is root 2. And the last one, negative 270, let's add 360 there. So you get cosecant of 90. So 90 degrees is a cool one, that's right there at the top. So we want the y value, and the y value at the very top, we should know that's just 1. And if you flip 1, you get 1. So that is the answer. And we're done. Next example. Find the quadrant in which angle theta lies. So if sine theta is less than 0, what I want you to do is think sine corresponds to y. So y is less than 0. Cosine corresponds to x. So x is less than 0. So let's draw this out. If they're both negative, well, think about it. It can't be quadrant 1, 4, or 2. Got to be quadrant 3. That's the only quadrant where they're both negative. So it seems pretty straightforward. Let me give you a second example. What if tan were positive and secant was negative? Well, this is trickier because tangent is the ratio y over x. So the ratio is positive. Secant is 1 over x is negative. So let's think about it. If 1 over x is negative, well, that would mean that x is negative. And if x is negative, that means it couldn't be quadrants 1 or 4. But the ratio is positive, which means y must also be negative. So that is, again, quadrant 3. Okay, here's our last example for this part. Find the reference angle for each of the following angles. So to do this, obviously, we need to define this word, reference angle. And reference angle, put simply, is the positive acute angle made with the x-axis. So for 150, imagine we draw it. That's about right there. 150. The reference angle is that little bitty piece right there. The positive acute angle with the x-axis, and that would be 30. Negative 45, that's going down. So notice how it already is acute, it's just not positive, right? We want this part. So just make it positive. 45. 9 pi over 4. So we can actually do a mixture here. We can actually subtract 2 pi to make it easier. And that would be pi over 4. And that's great. Hopefully you realize that's just in quadrant 1. That's already positive. So pi over 4 is your answer because it's already acute and positive. And negative 5 pi over 6, I'll draw that. That's negative 150. That'd be like over here. So we want that little bitty piece that's left. That would be 30 degrees, or do in radians, pi over 6. Okay, now you're going to work on the next problems. Once you're done, we'll start right here. So for this next part, we're going to do the tan values. So in our last class, we covered the sine and cosine values. So now for tan, I'm going to give you the tan shortcut here. 0, root 3 over 3, 1, root 3, undefined, negative root 3, negative 1, negative root 3 over 3, 0, positive root 3 over 3, 1, root 3, undefined, negative root 3, negative 1, negative root 3 over 3. So those are going to be the tan values. And I got that by simply dividing all the numbers. And notice how a pattern kind of comes out. And just how we had small, medium, large for the cosine, for tangent, we also have that. The tangent small value is simply root 3 over 3. The middle is 1. And the large is root 3. And the way it works is it follows the y, meaning as y gets bigger, tan would also get bigger. And if y gets smaller, tan also gets smaller. So that way you can use your tan values very similar to the y values. So I do recommend you memorize that little table. It will help you figure out all the tan problems much faster. So for example, if you want tan 60, 60 is right there. Think of the y, so that's going to be large. And this is positive because it's quadrant 1. So large positive would be root 3. 11 pi over 6, that would be right there. So if we follow the y, that's small. Quadrant 4 is negative for 10. So small negative would be negative root 3 over 3. 8 pi over 3, a little tricky. Let's subtract 2 pi. So that becomes tan of 2 pi over 3. 2 pi over 3 is right there. So that's large negative. Answer is negative root 3. And that's how you can do the tan values. Okay, last two examples here. So this will be pretty similar to the last problems you did. It's just giving you less information. So it gives you some cosine function is equal to negative 2 over 3. It also gives you this thing. This theta is between two numbers. This tells you the location of triangle. So that's going to be super helpful. So I'm going to draw an axis here. If you think about 0 right there, this is 180 or pi. So that's pi over 2. This is 3 pi over 2. If you're between pi over 2 and pi, you have to be in quadrant 2, which means our triangle is right here. Now fill it in. Cosine is negative 2 over 3, so just write 2 over 3 for now. And we know that the hypotenuse can't be negative, so that makes sense that the x bar is negative, since x is negative in quadrant 2. Do the Pythagorean theorem, and you're going to get the root of 5. There's your theta. And now we can answer everything. So at this point, you should feel pretty comfortable. Sine, cosine, tan, cosecant, secant, cotan. Sine is root 5 over 3. Cosine is negative 2 over 3. Tan is negative root 5 over 2. And just flip everything. 3 root 5 over 5. Negative 3 over 2. Negative 2 root 5 over 5. Now for this next one, it's a little tricky because it says tan is negative 4 and sine, so let's write y is negative. So let's draw our axis. So if y is negative, that means it couldn't be on the top, so let's cross those out. And if tan is negative, that means you couldn't be quadrant 3, because tan is positive in quadrant 3. So we got to be in quadrant 4. So let's draw this in. There's our theta. If tan is negative 4, you know that this is 4 and 1 for O over A. And the 4 has to be negative because that's going down. Do the Pythagorean theorem. This is root 17. So now we're going to get sine, cosine, tan, cosecant, secant, cotan. And now look at your triangle. Sine is over h, so that would be negative 4 root 17 over 17. Cosine is 1 over root 17, which is root 17 over 17. And tangent is given, that's negative 4. Now flip everything. So a lot of people want to write 17 over 4 root 17. Don't do that. Look at your triangle. Sine is over h, which means cosecant should be h over o. So that's simply negative root 17 over 4. So secant should be root 17, and cotan should be negative 1/4. And we are done.